Spring Boot is the most widely used framework in the Java world. And one of the most common usage scenario is building REST APIs using some kind of a database backend like relational database or NoSQL database, whatever. And there are plenty of resources to learn how to build REST APIs using Spring Boot. And it is really very easy to quickly get up and running and build a simple REST API using Spring MVC and Spring Data JPA, like that. But the challenge is how production ready they are. Like you can quickly build a prototype in just 15-20 minutes and it could be working fine. But is that production ready? But usually when you think of production readiness, there are a lot of things that you need to take into account. Is the code maintainable? Are we following the best practices? Are we by mistake doing any anti-patterns? So we need to take into all this into account when we think about putting the code into production. So one of the challenges when we think about following the best practices, there is no silver bullet solutions. When somebody says best practices, most likely they say in a certain context. What is best practice in some application might not be a best practice for some other application. That could be an overkill for some other small application. So it is really important to understand why something is called a best practice or something is called an anti-pattern. It is really important to understand them so that you can take a call like, okay, for my application, I don't need to use that best practice because that's not really helpful in my particular scenario, something like that. Also, it is very important to understand anti-patterns because most likely an anti-pattern is some kind of a bad practice that's going to come back and it is going to cause a lot of trouble in the long run. So it is very important to understand and avoid them from the very beginning itself. So what we are going to do in this video is we are going to take a simple Spring Boot application that I have already built here, and it is very simple Spring Boot application with a CRUD operation on a certain entity, and we are using some SQL database, Postgres or H2. And in this simple Spring Boot REST API application, there are a wide range of anti-patterns being used. So here I have listed a bunch of things that I consider as anti-patterns, and we are going to go through each of these anti-patterns and then discuss why it is an anti-pattern, and then gradually we are going to fix all of these issues one by one. Okay, so let's get started. I have cloned this repository and opened in my IntelliJ IDEA. So let us quickly go over what is there in our repository. So it's a simple Spring Boot application and we are using maven, and here we are using the status web validation and we are using Spring Data JPA, and we have both PostgreSQL driver and H2 database driver and then starter test. So it's a very simple Spring Boot application, and let us go over this implementation. So in our code we have what we call typical package by layer based packaging structure here. So we have web layer, we have service layer, and we have repository layer. And in our application we have only one entity called person. So here we have person entity with name, email, password, date of birth and active, and a set of phone numbers. So it's a very simple entity. And we have a web layer and we have person controller in which we have implemented basic CRUD operations, create, read, update, delete operations. And this is the first API endpoint to fetch all the people, all the persons from the database and then return as a response. And then second one is to get a single person details for the given ID. So we have this API endpoint, and the next one is to create a new person resource, and then we have update person and then we have delete person. So basic CRUD operations, and we have service layer, but as of now there is nothing much logic. We are simply delegating the calls to repository. There is no business logic involved. Okay, and repository is, again, we are extending JPA repository, and for one use case we have written a custom method to log in the user. Okay, so it is a very simple one. There is a models package in which we have login request. So there is another controller called login controller, which we are taking the login request as a payload, and then we are trying to log in using email and password. So it's a very simple API endpoint. So this is all the application we have, and then there are a couple of tests also. This is the default one, we don't have any implementation, and there is a person controller test, which is a web layer test. So we are creating a mock person service, and then we are invoking one API endpoint, and then we are asserting this. And then there are repository tests. I have created two for demonstrating two different scenarios. Again, we are creating a test and then injecting person repository and then asserting something. And we have another test which is using data JPA test, auto-wiring this person repository and then asserting something. So we have very basic, and we are going to explore everything in detail. But as you see, the main production code is a very simple one with basic CRUD operations. But there are, as I mentioned, a plenty of bad practices followed in that code base. So we are going to take a look at each one of these and then gradually fix each of these issues. Let us start with the first one. Not following REST API conventions. No proper URL structure, not returning proper HTTP status code. So let us take a look at our controller implementation. So here in person controller, we have API endpoints like /API/get all persons, /API/get person by ID /ID, so like this. But basically the REST API conventions are, to speak in a very simple layman terms, it is like when you think of your application, you can think of there are a bunch of resources. For example, let us take an example of a simple blog application. In blog application, what kind of resources we usually have? We have posts, and we have comments, and we may have users. So like this, these are kind of a various types of resources. And in our application, whatever we do, we can broadly categorize as various actions that perform on these resources. And also we can broadly categorize all these various types of actions into CRUD operations. We may not be able to fit everything into these CRUD operations, but broadly we can categorize them into one of these actions. For example, you may create a new post, or you may update an existing post, or you may get a list of all the existing posts, or you may get one particular post by some slug or ID. So you perform various actions on these resources. So how do we model this behavior? By following REST API conventions. So instead of coming up with some custom protocols and everything, the idea of REST API is to leverage the HTTP protocol and various HTTP methods available. And by combining these two, we can simulate all the kind of operations that we can perform on any of these resources. For example, okay, if we want to get all the posts, it is basically retrieving the information. So we can use HTTP method get, and let's say we can prefix it with /API to indicate that this is not a rendering a page. It is like an API call. So we can use some prefix like /API, and then we can mention just posts. Combining this HTTP method and then this, it could indicate that we are getting all the posts. We don't need to say get all the posts or something like that. It is kind of we are getting it. We can infer that based on what kind of a HTTP method we are using. Similarly, if you want to get one particular post, we can use something like this. Again, this is a get operation, and we are getting one of the resource, and we can pass that a dynamic ID, whether it can be an ID or it can be a slug, whatever it is. So you can fetch one of the ID like this. Similarly, while creating a new resource, a new post, you can use post HTTP method, and this is a collection. We can call this as a collection endpoint because it represents a collection of posts. So here we are posting one new resource into this collection. And how about update? So we are going to update one of the existing posts. And how do we identify any particular resource? There can be one of the unique identifier. In our case, let's say ID. And again, there is one common discussion whether should we use put or patch. The basic idea is you use put to replace an entire entity data, or you use patch only if you want to patch the data with only passed in information. Okay, so patch is not widely used, but let's limit our discussion to these common operations. So here another one is delete. So we can specify, okay, delete this particular resource. So again, these are called high level API endpoints. So now how do we get a set of comments for a particular post? So the idea is, again, that is a get operation, and you can model it as API / post / a particular ID and comments. So this is a sub resource of one of the post. So this is how, again, when you want to create a new comment for a particular post, how do you do? We can use post, and then like this, you post one of the new comment to this API endpoint. So this is how you perform various types of operations on various resources by combining a kind of a URL patterns with an appropriate HTTP method. So this is how we should model our API endpoints. So let's again, couple of things that we need to understand is this is doesn't mean that it is going to be a one-to-one mapping with the kind of a database operation we are going to perform. For example, while deleting a resource, it need not be like a delete one record or a set of records from the database. Maybe it doesn't. For example, let's take an example of a order management system where a cancelling order can be seen as two different things. For example, it can be considered as a deletion of a resource, but practically nobody is going to completely delete the record. There might be a column that indicates whether this particular order is cancelled or not, and you may put, okay, cancelled is true, something like that. Basically, it's an update operation. But conceptually, you can think of it as you are removing a resource, order resource. So in that way, don't go by directly like, okay, when I am post, I am supposed to insert a record into database. It's like a broadly you think of what kind of action you are going to perform on a certain resource. So that's how you can use one of these appropriate HTTP methods. Again, like when you are creating a new resource, maybe you will do multiple things. First, you may read some data to check for duplicate information, and then if there is no existing user or with a given email ID, you may create a new resource then. So a single API endpoint would perform maybe multiple database operations. So don't correlate every API endpoint should do a corresponding database operation like insert or delete, update, something like that. One API endpoint might involve multiple database API calls. So considering all this, let us go ahead and then rename all these API URL patterns. Let's change this to API/persons. And let us rename it to API/persons/ this dynamic value. And again here it can be simply API/persons, and it can be API/persons/ID, and for delete also API/persons/ID. So this is fine, but again if you notice, this API/persons is a common for all these API endpoints in this controller. So what we can do, instead of duplicating for every API endpoint method, we can use @request mapping and put the common prefix over here like this. And then you can remove here you can simply mention get mapping, and here you can remove this and put /id, and again you can remove this and like this. Okay, so this is how we can use appropriate URLs following the REST conventions. Okay, so let us see in login controller it has /API/login. It looks fine. Okay, cool. Now going back to our readme, here I can see no proper URL structure. This is taken care. Next, not returning proper HTTP status code. So here right now we are having various API endpoints, and by default if the handler method return response successfully, it is going to return with 200 status code okay. And here that is fine for both get all persons, get person by ID, but for create person, as I said, logically it is kind of a creating a new resource, and for this operation the respective HTTP status code should be HTTP created. Okay, so how do we return instead of the default 200, we should return 201 created. So what we can do, this is one of the way, like here you can say response status, and you can specify HTTP status dot created. So when you add this annotation and when you invoke this API endpoint, it is going to perform this action, and if it is successful, it is going to return the response, in this case person, and the status code would be 201 instead of 200. Okay, this is one of the approach. Here you can instead of returning person and then returning this status code using this annotation, another approach would be to return response entity of person, and then here you can perform whatever the logic you want to, and then you can return response entity status and body, whatever the response. So conditionally, let's say you have some complex logic here, and based on the situation you want to return with a different status code, you can use this approach as well. Okay, so for now let us go ahead and just use annotation based approach to return 201 status code. Okay, so this is fine. For put mapping, this is fine, or returning okay is fine. And again this is up to you. Like for deleting, basically we are not returning any response here. Some people prefer to return response status no content, but anyway, whether you want to use okay or no content, you need to stick to some consistent approach. Okay, if you want to return okay, maybe that is also fine, but if you want to strictly follow, like here we are not returning any content, we are simply returning the status code, you can specifically mention return no content. Okay, so this is how we should follow REST API naming conventions for URL and returning the appropriate status codes. Okay, so here the first part is taken care with these changes we have made so far. Next, let us take a look at what using field injection and why it is a bad practice, and how to fix it. So basically, if you take a look at our person controller depends on person service, and we are using auto void on the field itself, so it is called field injection. And again, if you take a look at our person service, we are depending on person repository, and we are using field injection again for person service as well. So why it is a bad practice, and what are the alternatives we have? So in Spring we have three different types of injection mechanisms available. So the first one, field injection, like we saw, there is person controller and we are using auto void on the field itself. This is called field injection. Another alternative is setter injection. So here person controller, it has a field called person service, but instead of using field injection, here we are injecting its dependency through a setter method. Okay, and we are using at auto-void on the setter itself. So this is called setter injection. And the other alternative is constructor injection. So here person controller depends on the person service, and the person service dependency is injected through a constructor itself. And here we have auto-void, but it can be an optional. If there is only one constructor, you don't even need to add this at auto-void. So these are the three ways you can inject the dependencies. But why field injection is considered as a bad practice, right? That is the question. So often you hear things like, whenever you use auto-void on the field injection, a unit test dies, right? So let us understand why is that case, why using field injection makes it difficult for tests, right? So here we have person service and it depends on the person repository. Now we can write a unit test using Mockito and still make it work. Like here we are using this extends with Mockito extension, which behind the scenes takes care of creating these mocks and then injecting them. So here first we are declaring this person repository and then adding this at mock annotation. So Mockito is going to create a mock object of type person repository, and then it is going to create an instance of person service and inject all the dependencies it needs using this annotation. So it is going to inject this person repository into this person service, most likely using reflection. But the point is, unless you use some library's magic power here using Mockito's reflection, you will not be able to create an instance of person. So instead of using this mock or inject mocks, what if I just want to use plain new operator and try to create an instance of person service? Can I do that? So let's say I want to use the setup method to create an instance of person service. So what can I do? Let's say for person service, I can say mockito dot mock of this person repository class. So this way I can create a person repository mock. But here I cannot create a person service by passing this mock instance, because it is not exposing in any way to inject this dependency, because it is being injected when you are running your application using Spring. Spring is taking care of doing its magic and then injecting it. When you are writing tests using Mockito, it is doing its magic and then injecting this through annotations. But if you want to simply create an instance or mock and then try to construct an object of person service, you will not be able to do that. So here you may ask, fine, I will go with Mockito and that works fine. I will use these annotations and I can still write tests, right? So why? So here are a couple of things. So just because you can make things work doesn't mean you should do certain things, especially when this is kind of preventing you to do things in the right way. So again, when I say right way, so suppose you want to use person service and you want to construct an instance of person service, and as a consumer you want to know, how can I construct an instance of person service fully functional and working? So right now it is not giving any opportunity like to construct a fully functioning person service object, because you are relying upon the frameworks or libraries magic to inject these dependencies. If you want to use it as a plain library or something like that, you are not able to do this. So that is the trade-off. You can rely upon the framework magic and lose the ability to simply create an instance. And especially, let's say you are building some kind of a reusable component where you want to allow your consumers, your API consumers to switch different implementations of its dependencies. You are not allowing them. You are relying upon the frameworks or libraries magic. And again, you need to consider trade-offs here. So is it that difficult to use constructor injection instead of field injection? Let's say if you want to follow some standard pattern instead of using frameworks magic, so that you can write framework independent way. And if it is so difficult, then I would say, okay, I don't want to implement in such a complicated manner, so instead I can rely upon the frameworks magic, and fine. But if it is so simple, like here you can see the ID itself is showing the warning as field injection is not recommended, and it is also giving an option to simply change it to constructor, make this field as a final one, and then inject through constructor. It is as simple as that. So when it is as simple as that, why not simply do it in the right way? Inject this dependency. So anybody looking at person controller and thinking of, okay, I want to create an instance of person controller, and how can I do that? It is explicit that you need to pass a person service dependency. Whether you do it for whatever reason or let framework do it, it is very obvious and explicit. So I would say always go for constructor injection. And another one is, you may think, okay, why not use setter injection? Why should we go for constructor injection? So my reasoning would be like, when you are creating an instance of an object, after you constructed that object, it should be fully constructed and ready to use, right? But if you use setter injection, it would be like, first you create an object and then you expect the people to call the setter injection. So they may forget, or it is kind of a two-step process. Before calling the setter, you have created an object and it is in a broken state. Because if somebody, without calling the setter to inject the dependency, if they call some other method, it's going to most likely throw null pointer exception, right? So to remove all those unnecessary headaches, simply follow constructor injection. That's it. You don't have to worry about, okay, whether I am using frameworks magic, whether I am using test library magic, it doesn't matter. You simply follow constructor injection and you construct it or framework construct it, it works all the fine. And you are giving the ability to anybody who want to change. Maybe they want to pass in a different implementation of person service. So you are giving that luxury to your API consumer. So follow constructor injection. So let us change that. So here we changed in controller, and let's go and again change this. Okay, and again it is like you can make it as just an instance variable, but making it final force you to instantiate, initialize within the constructor itself. Okay, so this is the pattern that I usually follow. Always make your dependencies final variables and then initialize them by the end of the constructor itself. Okay, so yeah, and now we have taken care of using field injection. Let us see. Okay, here is another place. Now I think in all the places we have changed the field injection to constructor injection. So this is taken care of. Next, let us look at not using pagination for collection type resources. So here, if we go to our person controller and our first API endpoint get mapping /API/persons, here we are going to fetch all the persons from the database and then we are returning as a list. So the problem with this is, let's say if usually during the development we hardly insert a few 10 or 15 records and then you invoke it and then there is nothing problem. You just check and it works fine. But once you deploy into your production, and then over the years number of records keep on inserted into the person's table, and it can end up having millions of records in the table. So when you invoke this API endpoint, in that case it is trying to fetch all those records and most likely end up in a out of memory exception. So whenever you are exposing an API endpoint and you are getting the data from a table which is kind of a grow over the time, it is always recommended to use pagination, so that only you return a small subset of the data and you give the ability to users to fetch page by page manner. So let us try to do that. So the first thing is, for the sake of discussion, here we expect only users to specify the page number, and if they don't specify it, return the first page. And optionally you can also support specifying the number of records per page, but for the discussion let's keep it simple. So here we can say request param and specify default value page number. So if users pass explicitly page number, we are going to use that. Otherwise, if they don't specify anything, we are going to use default value as 1. Okay, once we have that, let us pass it to page number. Now let us go to get all persons, and here it's going to have page number. Now Spring Data JPA provides various options for pagination. Let's say if you just want to sort, you can specify only sort option, or if you want to fetch based on a specific subset of the records using pagination, you can create this pageable instance and then pass it. So let us construct a pageable object, pageable. So there is page request, which is an implementation of pageable, and you can pass. So here this pageable, it's a 0 index based one. So from user's point of view, we want to say page number 1, 2, 3 and like that, but from the pageable point of view, it is a 0 based index, so we are reducing it by 1. And here again, as I mentioned, for now let us say keep it as page size as 10. But the important thing is, whenever you are using pagination, always specify sort option. Otherwise, the results are going to be non-deterministic. So always mention sort option here. So here we can say sort by ID ascending. So whatever the default criteria that you would like to follow, you can specify that. So here what we are saying, we have constructed a pageable instance by specifying the current page number that we want to fetch and what is the number of items per page, and we are saying sort by ID in a ascending manner. Okay, and then we can pass that pageable argument. And so here I have added this logic to only fetch active users, but usually you would not do that in within the application logic itself. You typically do it by applying this filter on the database itself. So here just let us remove this. And what does this find all method by taking the pageable argument returns? It returns a page. So let us initialize this to page of person page. Okay, so here I don't want to leak this page which is coming from Spring Data JPA into the web layer. So I want to keep web layer completely independent of which persistence framework we are using. Maybe we can use a simple JDBC or Zook or something else. So I don't want to leak this page which is coming from Spring Data JPA, Spring Data Core, I think. I don't want to leak it to a web layer. So what I can do, I will create a paged result, a model object here. So here I have a simple paged result record which is taking a subset of the data, and I want to specify what are the total elements available and what are the total pages available, and or what is the current page that represents this results. So I want to return this from my service. So I want to return page result of type person. So how can I construct that? Return. So here from the page we can get content. So this represents the actual record, person records in the page result. And then we can also get what are the total elements available. For example, let's say in our total database there are say let's say 5,000, and you specify 10 or 100. Based on that, it calculates what are the total pages available, and you can also return the page number. But again, here we are incrementing it plus 1, because from the database, from the Spring Data JPA perspective, it is going to be 0 based index. So for the first page, it is going to return 0. But for the user, we want to show it as 1. So I am incrementing it. Just like the way we are decrementing from the user, we are incrementing for the presentation. Let's say we want to show it as first page as 1. Okay, that way we are going to return this to front end, I mean for the controller, and accordingly you can specify page result of person. So this is what I would recommend for any of the collection based resources. Okay. Next, let us look at not using request specific payload structures, using entities as payloads. So here, if we take a look at our person controller, for create a person API endpoint, we are taking the payload as person entity itself. Similarly, for update person API endpoint also, we are taking the payload as person entity itself. So what is the problem with this one? So basically, when we are building a REST API, and most likely we will publish it to some other people, like maybe a different team within the same organization, or maybe a completely different company, or open for public consumption. Then one of the common approach for documenting the REST APIs is using OpenAPI documentation like Swagger, right? So let us see how it looks like. Let's say we can use this library called Spring Doc OpenAPI, and we can add this dependency, which is a Spring Boot starter, which will automatically configure the necessary libraries, and then we will be able to look at the Swagger documentation like this. So here in our application, I have added this dependency, and let me restart the application. So now I can access the API documentation here. So now when I check post API persons documentation, it shows automatically the example payload. So when they look at it, like they may assume that, okay, we need to pass all this data, and they don't know that whether they should create the ID value and then post the payload, or whether we are going to generate the ID value. And similarly, it is a bit of confusion. Like let's say if they specify ID equals to 2 and then other data, is it going to ignore the ID value and create it as a new entity, or is it going to update the existing one for ID equals to 2? So it kind of brings some kind of a confusion. Similarly, for update API endpoint, we pass the ID value as part of the URL path variable, and also as we have used the same person entity as the payload, here ID is also present in this request body itself. So which value it is going to consider? Like let's say in the URL you pass ID value as 2, and in the payload by mistake or whatever reason you pass it as ID as 10. So is it going to update using this value, or the value that you passed through path variable? So again, most of the times you don't have one endpoint to update the entire data. Sometimes you may have granular API endpoints. For example, typically for updating the passwords, you have a change password or something like that, a specific separate API endpoint instead of updating as part of the whole entity. So all I'm trying to say is, instead of using generic payloads, typically entity itself, you should create payload structures that specifically depict what you are expecting from your consumers as part of the payload. Okay, so let us change that one. So here, instead of using person entity, we should create specific objects that represents the actual payload that we are expecting. Okay, so I'm going to create a new record called create person request. So here I am specifying only the properties that I am expecting to be part of the payload for this create person API endpoint. Okay, so here I am going to take this and use this instead of person. And one thing to remember is, like here, because I mentioned it as a request, it is not tied to HTTP layer. Sometimes some people prefer like a create person params or create person DTO. So you can name in whichever way you want, but be consistent. So I have named it as a create person request, and then we are going to pass the same to the service layer. Because this is not specific to HTTP layer, I am sharing it, like I am passing this to service layer itself. So here I am going to take this and then I will prepare. Okay, so here person, I will take name and email, password, DOB, and phones. So here I am expecting all other fields like name, email, password, DOB, and phones, but I am not initializing the ID value. I am expecting Spring Data JPA to automatically generate it, and also by default I am creating a person who is active. Okay, so I create the person and then saving it. Okay, similarly we will go for creating another model, update person web request. So here you might think about why it is a web request, not update person request, similar to create person request. The reason being, so here we are modeling it for web request payload itself, which doesn't contain ID value. ID value comes from the path variable. So we are going to take this and we are going to use it for update payload. However, we need to pass ID value also for this service. So what we are going to do, we will create another record called update person request, which takes all ID, name, and DOB. So here my intention is only if the update API endpoint is allowing users to change name and DOB only, not password, not email. So we are going to create the request accordingly, request payload. And then I am going to create okay, so here we are using this ID value which is coming from path variable, and then we are taking the name and DOB from the payload, and then we are going to pass this to service layer. So let us take this. So here what we are going to do, first we are going to load the entity from the database, and if it doesn't found any person with the given ID, it is going to throw an exception. Otherwise we are going to update this person name and person DOB and then saving the person. Okay, so now with these changes, now if we go back, let's restart the application, and if we go back to our Swagger documentation. So now when we take a look at our post API persons, it is clear that what we are expecting explicitly, like there is no ambiguity, like okay, should I pass the ID value or not, what happens if I pass the ID value. So it is clear that you don't pass ID, it is going to be generated automatically. And similarly for put request, it is clear that okay, only these two fields are acceptable as part of the payload, and this ID value should come from the URL itself. So there is no confusion what is going to take priority. So this way it will be very clear, like maybe you think okay, we are creating so many classes and all, but in the long run it gives a lot of clarity that especially REST APIs are built mostly by for sharing with other teams, and it is very important to be clear on what is the expected payload and what is the expected response. It is very clear. And I haven't customized the OpenAPI Swagger configuration, like you can put Swagger documentation annotations that specify okay, what is the example request and response payloads look like and all that, but you get the point. So here the main point that I want to stress: use the specific request specific payload structures. Don't use generic ones like entities and all. So it will give more clarity on this one. Next, let us look at using JPA DDL auto generation. So when we create our application, we have added both PostgreSQL and H2 database, and so far we have not configured any database specific properties. So by default it is using H2 in-memory database. And probably you can configure to a Postgres database. Maybe you are running an instance of Postgres and you can configure the data source properties here. And then there is currently we are using only person entity, and also we are having an association element collection, and we are expecting to have a phone numbers table. And right now we have not configured any database, so by default it is using H2 database. And when you are using Spring Boot with any in-memory databases, by default it enables automatic generation of the database structures. For example, usually you can configure your application to generate or update the database schema by configuring this property like Spring JPA Hibernate DDL auto. You have various values, whether you want to create or you want to update, create and drop, so various values. This option, in addition to this option, there are various other options as well, like you can create schema.sql or data.sql in SRC main resources. That's another way to instantiate. But all these options are okay for a quick prototype or proof of concept or exploring some other features. But for production, this is definitely a big no. It should not be an option for running the application in production. So what is the problem? What happens if we use DDL auto with update option? Like if there is any changes in our entity, it will try to figure out what are the changes, and it automatically applies to the database, right? So why can't we use it? So the problem with this kind of options is, let us say you have this entity, and right now you name it as the property, name it as name. Suppose you want to change it to full name. So what happens? Let's say you change it to full name, and your intention could be to rename this existing column. But what happens if you change it like this and then you restart the application, hoping maybe the name column would be renamed to full name? No, it's not like that. What is going to happen is, it is going to leave the name column as it is, and then it is going to create a new column called full_name or something like that, which is definitely not what you might want to happen. And not only this, like if you do by mistake, typically in any applications, your data is far more important than your application code. Like if you lose the customer data, that's the end of your business. So making any changes to the database is very critical, and you shouldn't let your code changes affect that directly. So it should be a conscious decision. If you want to make any changes, you should make that database changes specifically like that. So the recommended approach is to use any tools like database migration tools like Flyway or Liquibase. Okay, so if you don't have Flyway or Liquibase kind of a setup, the problems are like in big applications, it is not simple table structures and all. Maybe you have some stored procedures, you may have some other triggers, things like that. So in some way you have to document all that and then keep track of how many of these SQL scripts we have already applied and what are the pending things. So it becomes complex and complex. So these tools like Flyway or Liquibase, how you are going to use it is like you store all these migrations in a specific folder or somewhere, and then when you start the application, it will check what are the migrations that have already been run. It keeps track of all these things in a table, and then if you add any new migration scripts, it is going to execute only those new things which are not yet applied. So it becomes like a versioned changes. You can figure out, okay, when this particular change is introduced and what are the pending migrations that we still need to apply. So it is all kind of a very automated process. So let us apply that one. So right now it is getting automatically generated using this Hibernate auto generation. So let us use Flyway and then use migration scripts for that. So first let us add the Flyway. You can use Flyway or Liquibase, whichever you prefer. Personally, I prefer to use Flyway. So let me add this dependency. Okay, so Spring Boot has auto configuration support for Flyway. So by just adding this one, it will auto configure, and all you need to do is under resources, create a file under db/migration/v1__, let's call it as init.sql. So here there is a specific naming convention that you need to follow. V sequence number __ as a separator, and you can give any descriptive name you want, and here you can write a SQL script. So here, instead of automatic generation, I'm going to specify this table definitions over here. Okay, so I have created a sequence and then created persons table, and I have created a phone numbers table where for each person we are going to hold one or more phone numbers. So we have this Flyway based definition, and you can remove this. Okay. Now let us restart. So here now we can see Hibernate is not performing the database setup process, and here we can see Flyway is applying this migration scripts and creating the schema, database schema. So that is one of the very important thing for production based applications. So using JPA automatic DDL generation is maybe good for quick prototypes or demos, but definitely a big red flag to use in production. Now let us look at misusing Spring Data JPA derived query method names. So if you are familiar with Spring Data JPA, you know that there is a facility called derived query methods. So in our person repository, we have created a custom query here, a custom method, find by email and password and active is true. So we don't need to actually implement this. Spring Data JPA figures out what to do with this method and automatically generate the query based on this method name. How does it does that? So it removes this prefix of find by, and then based on this it will try to create a where class applying on person table. So how does it do? Email and is nothing but another where class and operator, and then password and active is true. So it is going to generate the query like select star from persons, where email equals to whatever the value we are passing here, and password equals to whatever the value we are passing here, and active equals to true. So it is going to figure out all that by using this method name itself. You don't have to actually implement this, but it looks like a nice idea. And typically if it is only based on one field or max 2 fields, it is fine. But right now it is like on 3 fields, like for this is for login, so we want to compare with email and password, and also make sure active is true. So already this method name becomes so much lengthy. And in real world projects, it's not only active, there could be other things as well, like whether the account is logged, whether it is not yet activated, or whether it is disabled. So if you try to derive all that complex logic just by using the method name, it is going to go on and on, like it is and active is true, and disabled equal to false, and locked is false. So it is going to go on and on and on. So this is definitely not a preferred approach. Instead, you should use a meaningful name and then use query annotation to define that. So what we can do, let's say here create a method with name login and password and use at query. So here you can pass something like, you can specify select P from person P, where email equals to this and password equals to this, and active is true. Okay, so instead of using this method name derived query, you can explicitly specify this and use meaningful names here. Okay, so here instead of this, use log. So it is kind of a very tempting, like okay, why should I write this thing, instead let Spring Data JPA figures out by this name. As I mentioned, it looks cute if it is only for one property. For example, if you want to get a person by email, definitely go for find by email. Or if it is even for 2 fields, maybe you can go ahead, or beyond that it's going to get ugly. So if you are going beyond 2 fields, I would highly recommend to use query, and also use meaningful names here. Okay. The next one is loading entire entities and using only a small subset of fields. So in many business applications, there is kind of a screen where you will be shown a list of records with only a very few details, and then when you click on one particular record, you will be shown a lot more data about that particular record. So in the first screen, the listing screen, usually you don't need to load entire data about each record. Hardly there will be kind of maybe even each record may contain 20-30 fields, but in the list table probably you will show only 5 or 6 fields. So in that case, for that collection query, loading the entire record and only using kind of a very small subset of data for actual projection for on the screen is a lot of resource wastage. You load the data, you put button on the database, and then you carry all that data in the memory, and a lot of data transfer between client and server. So it's all kind of a very waste. So instead of loading the entire entities, if it is not required, you should only load the data that is absolutely required for that API endpoint. So let us look at our person control. So in our get all person, this API endpoint, we are already taken care of pagination thing, but still we are returning all the person details. So here we are calling get all persons, and again internally we are calling person repository dot find all. So it is going to fetch all the data about the person, but probably all we want to show on the screen is kind of a name, email, and we don't want to show password, maybe date of birth or something like that. We don't even want to show phone numbers. So in that case, loading the entire data is kind of a wastage of resources. So what can we do? So the usual convention is, if you want to modify an entity, you load the entity, change its value, and persist it back. But if you want to just load the data for read-only purpose, most likely you would go for some projection. Projection in the sense, you load only the data for read-only purpose. You don't make changes and then try to persist it back. The projections are for only read-only purpose. So we are going to change this logic to use projections and load the data that we are interested for this particular API endpoint. So what I'm going to do, I'm going to create a record called person basic view. So here I'm going to create a model called person basic view, which is a simple record, and which contains only ID, name, and email. Probably these are sufficient details for this API endpoint, just for the example. And what we can do, let us go to our person repository. So right now we are calling this find all method, which is inherited from JPA repository or one of its parent classes. So instead, let us go ahead and create a here page of person basic view find all by pageable. Okay, so I have instead of returning page of person, I am returning page of person basic view and giving the find all by and passing this pageable argument. Okay, so now I am going to load this and I am going to use that method, and instead of returning person, I am going to return person basics view, and the return type also I would change, and here calling this. Okay, so now let me restart the application, and if I go to Postman and try to fetch all the persons, so right now it did not return any data, but if you take a look at the query, it is only loading ID, name, email from persons with pagination support. It is not loading all the data. So this way we can limit the number of fields that we are loading from the database and then all the way passing to the client. We can limit, which obviously makes it much faster. Okay, so that is what I'm referring to. This loading entire entities and using only a small subset of fields is not a good pattern. You should load what data you want for that particular API endpoint. The next one is using JPA that results in N+1 select problems. So what is N+1 select problems? Let's say you are trying to fetch a list of entities, and each entity may have association to one or more other entities. So now when you try to fetch a list of entities, it will issue one query to fetch all the list of entities. Let's assume it returns n records. And for each of these n records, it also needs to fetch the associated records. Like let's say user has a list of one to many associated addresses. Now when you try to fetch a list of users, first it will issue one query to fetch n users, and then for each of those n records it is going to issue another query to load associated addresses. So this is a common problem in many of the JPA based applications, mostly because the developers are not familiar with it, or they are not checking what kind of a queries it is generating behind the scenes. So to demonstrate, I have created such a example here. So earlier we have this get all API, get all persons API, right? So I have created another one just for the sake of demonstration. I have added a different endpoint /API/persons/all, and as I mentioned already, this is not a good practice, but I'm creating this API endpoint for demonstrating N+1 issue. So here I have this API endpoint and I am calling get all person entities. I have copied the earlier method and made some changes here. So here again we are using pagination, but we are calling the inherited find all method, and which is returning page of persons. Okay, and we are entering this. So let me start the server. Okay, just to set up some sample data in Flyway migrations, I have created the second migration file and inserted a bunch of records into on phone numbers. So I have some sample data. Now I'm going to call that API endpoint /API/persons/all. It is going to return some data here. But now if we go to check, so here you can see it issued whole bunch of queries. How? So this is the first query that is trying to fetch persons, and it returned assuming 10 records. And also it issued another query to find the total count of records. So this is expected. But the problem is for each of those 10 person records, it is issuing another query to fetch the associated phone numbers for that person ID. So 1, 2, 3, 4, 5, 6. I'll assume there are 10 records, and it is going to issue 10 additional queries to fetch the associated phone numbers. So this is called N+1 select problem. So this is very bad. It is going to issue a whole bunch of records instead of using a join. So that is a problem. And that is the reason when you are using JPA or Spring Data JPA, though it is very convenient, you simply call some method and get it done, you better check the console and profile how many queries are getting triggered for each operation, and then see if you can improve upon it. So basically what I would do, instead of using the default find all method, I would create a custom query, custom method, and use @query annotation, and then join the associated tables that I want to fetch data from. So let me try to do that. So here in person this, I am going to return page of person find all entities by pageable. Okay, and if I leave it like this, it is going to try apply the default mechanism, and it is going to return same behavior. So instead I would like to issue a custom query. So here I am going to left join fetch phone numbers. Okay, so instead of issuing separate, I'm going to issue distinct P from person P, left join fetch P.phones. So I don't want to issue separate queries to fetch the associated phone numbers. Instead, I want to perform the join and fetch it in one go. Okay, let me restart, and I need to use this. So instead of find all, I'm going to use find all entities. So now if I issue So I got the result, and if I check, it is issuing only 2 queries. So here first query is to fetch all the persons, and also here if you notice, from persons left join phone number. So it is issuing only 1 query to fetch both the main entities and its associated data, and the second query is for getting the count. So this way you need to customize the queries, though it is very convenient to call the inherited methods and be done with it, but behind the scenes it may issue a lot of queries, which is obviously going to slow it down your application performance. You need to profile what are the kind of queries that are being generated behind the scenes, and then try to improve upon it. Okay. The next point is not implementing proper exception handling. So if we take a look at our current code, like there is no exception handling. We are not handling any exceptions. Of course, right now we don't have much business logic, and also there is very less scope that we may probably get any exception, but in the real world projects, it will be a complex business logic, and there is a scope for things may blow up. And if when things go wrong, obviously you shouldn't be throwing some generic error messages or even throwing the stack traces to the clients is not really a good idea. You should always catch any of these exceptions and then provide some proper error messages as JSON responses. So how do we do that? So there are different approaches, like if you want to handle any of the exception in a specific way for a particular API endpoint, you can go ahead and try catch it, and then you can handle in whichever way you want. But that is the usual case. But how do you handle unhandled exception? That means maybe you have some logic in your controller or in your service or repository which you haven't, maybe a logic bug or something which you haven't verified. So it will throw an exception and none of your logic is handling that. So in that case, obviously it will left to the Spring framework to handle that and then show some response. So let us see with an example how that happens. For example, if you are invoking this /API/persons API endpoint with page number equals to 1, we are going to get the data as expected. And let us say if we are specifying page number as -10, let's see what happens. We got 500 internal server error with the default error message from Spring Boot. So this is the default Spring exception handling in place, and it is showing this way. The thing why it happened is page number is minimum, it should be 0, but based on the current logic, it is like it goes negative number, and the Spring Data JPA throws an exception, and this is what we are seeing. But probably this is not what we want to see. We may want to show some custom error response with some specific fields. So how do we handle that? So I have written a blog post on my blog covering this particular topic in very detail. So if you go to SivaLabs.in and if you go to tutorials, under which there is a Spring Boot tutorials link, and here there is Spring Boot REST API best practices exception handling part 4. So if you take a look at it, there is a good amount of coverage where how do you handle exceptions in a particular method, in a particular controller, or globally. So I would highly recommend you to go through it. And one feature that I would like to show is, like I mentioned, if there is any exception that you want to handle for a specific controller handler method, you can obviously try catch it, and then you can do whatever you wish to do. But if you want to implement global exception handling where you catch all the uncatched exceptions and then providing some proper response, you can use this mechanism called controller advices. Okay, so let us take a look at it. In addition to that, in Spring Framework 6, it also added support for this problem details API which is RFC 7807. So we can leverage this also. So let us create a global exception handler and try to handle unhandled exception. So let me create that, and okay, for now I'll put it in web. So here I have REST controller advice, and I am handling generic exception, copy paste issue. So here it's not found, it is internal server error. Okay, so here I am using problem details API, and then I am preparing some fields and then setting some custom properties here, and this is how I want to send the response to the clients in a standardized way following this problem details API. So with this one, now let us restart the server and invoke the same API endpoint with the negative page number. So now it is going to return a standard response according to the problem details API. You can specify some type and title, and you can provide more details. So by default, now it got page index must not be less than 0, something like that. Okay, so you can provide additional handlers. For example, here this is a generic exception handler, but if you want to handle other exception like okay, person not found or some other bad request, so you can provide more handlers like this, and then you can specify what is the status code that you want to return and what is the actual message you want to return. Probably you don't want to return actual exception message, instead you want to provide some other message. So you can handle all that using this global exception handler using controller advisors. So the next one is using @Spring Boot test for testing slices, controller, repository, etc. So basically Spring Boot provides extensive support for testing, and there are different ways you can test. Usually you use @Spring Boot test for integration tests, where when you use @Spring Boot test, it is going to load the entire application, and then you can run whatever the tests you want to run. In addition to that, it also provides what is called slice test annotation. For example, in our current implementation, here we have a typical 3-tier design, like we have controller layer, we have service layer, and we have repository layer. And Spring also provides this test slice annotations like @web-MVC controller test or @data JPA test. Only if you want to test controller part, for example, let's take person controller. So you want to test only the logic of your controller, and you don't bother about testing either person service or person repository or anything else. You just want to test the logic of your controller itself. So in that case, you can use @web-MVC test annotation. And also similarly, if you want to test only your repository, you don't want to load the entire application or services or controllers, you just want to test your repository. So again, depending on which technology that you are using, there are various annotations. In our case, we are using Spring Data JPA. So there is an annotation called @data JPA test, which you can use only for testing repositories. So these are various testing support Spring Boot is providing. And one of the common mistake is like people use @Spring Boot test for all the kind of tests. For example, here I have a couple of tests. So here we have person controller test, which is using @Spring Boot test, and auto configured mock MVC and injected mock MVC, and also we have mocked the entire person service. So what is happening? The intention could be we just want to unit test the controller, person controller, but when we are unit testing a controller, we need to provide the mock beans. Whatever a controller depends, we just need to provide some mock beans. This is how we can provide mock beans. in a Spring injection manner. Okay, and then you can set up based on your testing scenario. Here we are testing should get person by ID. So what we are doing, we create a person object and then we are mocking the behavior of person service get person by ID. We are trying to return this response, and then we are invoking API/persons/1 and we are asserting the response. So clearly the intention is to unit test person controller here, not to do integration test. But what is the wrong we are doing here? Using at Spring Boot test, which loads entire application, all your services, repositories, controllers, and everything it is loaded, and you just mock this person service, which is obviously unnecessary. So similarly here we have person service, and again we are loading the entire Spring Boot test using this annotation makes everything is loaded into the application context, and we are just injecting the person repository and then trying to test some scenario. Again, this is just for testing the repository, and unnecessarily we are loading the entire application context. So this is clearly wrong. What we should be doing here is, instead of using at Spring Boot test, we should be using at data JPA test. So this only loads the repositories, not the entire application. So now here if I run this, it should work fine. So it is working fine. And obviously it will make it this test faster because we are loading only the repositories, not the entire application. Similarly, if your intention is to only test the controller, instead of using at Spring Boot test, you should be using at web MVC test, and you can specify what controllers you want to test. So in our case, we want to test person controller. Okay, and when we are using at web MVC test, it already auto configures the mock MVC, so we don't need to configure it by ourselves. It automatically configured. Now let us run this test. So it is working fine. And if your actual intention is to write integration test, then you should definitely use Spring Boot test, which loads the entire application and then test it. Okay, so you need to be cautious about if you are testing, if you are writing integration test or slice test. If it is a slice test, use the respective slice test annotation instead of using Spring Boot test for everything. Okay. The next one is testing with in-memory database. So if you take a look at our application, first let us take a look at our pom.xml. So here we have Spring Data JPA starter, and we have PostgreSQL driver and H2 database. Most likely we might be using some PostgreSQL, MySQL or Oracle type of a database in our production. But we also add this H2 database. Many people do this because they want to use some in-memory database for testing. But this is a very bad idea. Why? Using some other type of database in production but testing with a different in-memory type of database kind of defeats the purpose. Like maybe you can think, okay, I'll write the code which works exactly same on H2 as well as Oracle or a SQL server. It may not be right. Like maybe your production database like PostgreSQL or Oracle provides a lot of features which H2 is not providing. So in that case, you cannot test those kind of features in your applications. Or vice versa, you write a test and using H2 database, it is working perfectly fine, and then you package your application and then deploy, and when it is actually trying to talk to the SQL server or MySQL, maybe the query syntax that you use is not compatible with the target database and it fails there. So the whole purpose of writing test is to ensure that it is working fine. but by testing with in-memory database, it is just giving the illusion that your code is working, but actually it is not working. It is both a waste of effort for writing this test, and you will get to know your code is not working only after you actually try to talk to the actual type of database. So the solution is, there is a project called test containers. It's primarily a testing library, but you can also use it for local development as well. But what it does is, it will help you to spin up whatever the database you want as a Docker container, and you can configure your application to talk to that database and then run your tests. So for example, in our case, we want to talk to the PostgreSQL database. So what you can do, you can configure test containers to spin up a PostgreSQL container and configure your application to talk to that one. And then once the test is done, test containers will take care of automatically deleting that container. So it helps in many different ways. One, it will help you to test with a database that you actually use in production database. It will use the same type of database. It is not a mock, it's not a test double or anything like that. It is an actual PostgreSQL database running in a Docker container. Second, when you are running your test in a pipeline, it will spin up a separate database container or any other container that you are using, and use it only for your tests, and then once the tests are executed, it will automatically delete those containers. This is very important to have an isolated execution of your tests. If you are using some pre-installed common database for tests in your CI pipeline, maybe multiple pipelines get triggered at the same time, and then one test execution may be conflicting with other test execution. Maybe you are trying to insert some data and then expecting n records to when you are trying to fetch the data, but meanwhile some other test is going to insert more records, and you will get n+10 records. So if you are using a common database from multiple pipelines, you will get unpredictable results, whereas with the test containers, each pipeline execution is going to spin up its own set of containers and then run your tests, and once the tests are done, it is going to remove all those containers. So clean. So that is why it is highly recommended to use test containers and then run your tests using real services instead of in-memory variations. So let us do that. So first I'm going to add I'm going to add this test containers PostgreSQL module here, and right now if I try to see, so here we have person repository test which is using data JPA test here. So if I run this one, by default it is going to configure a in-memory database. So here if you take a look at, it is using this in-memory H2 database. By default, if there is a in-memory database driver, it is going to use that and configure a data source based on that. And because we have H2, it is using that. So how can we say don't use H2 database and instead use test containers to spin up a PostgreSQL container? It is simply a matter of configuring these couple of properties. So usually test containers provides a Java API and you can define the container and all, but for specifically testing the database, it provides much simpler option using this magical JDBC URL, test containers JDBC URL. So usually your Spring data source URL is like a JDBC : PostgreSQL blah 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 blah, but here using this TC prefix, it understands that it needs to spin up a PostgreSQL container using this image and then auto configure rest of the data source properties. So testing with test containers for any database related stuff is as simple as that, adding these two properties. So having these two properties, now let us run. So one of the prerequisite for using test containers is to have a container runtime. So right now I have my Docker desktop running, so it is going to use Docker container runtime. And if we take a look at the logs right now, we should see using PostgreSQL. So here now take a look at this. So here it is spinning up a PostgreSQL container on a random available port and then run our tests. So that is as simple as it is. So instead of using in-memory database, we should always be testing with the same type of database that we are going to use in our production. So the last point that we are going to discuss is not using proper packaging structure. So currently, as we have talked about, it is a typical package by layer style of a code organization. So here we have models, we have web layer, we have service layer, and we have repository layer. The problem with this one is as the project grows, so the idea is we initially assume, okay, we have a person controller and it is going to use the person service, and which is internally going to use person repository. So it all starts like that, very beautifully, very well organized and all. But over the time, as the project grows, there will be other controllers and there will be other services, other repositories, and someday some use case might require, okay, a person controller might start using the other services, and one person service start using other repositories and all. So over the time it become like a tangled, like every controller talks to every other service, and even sometimes one service talks to various other sibling services, and every service talks to every other repository. It becomes a total mess out of it. So why it happens? One of the reason is because they are public, because you put them in a different package, and in order to make it available for other packages, you need to make it public. So you will make this public, and anybody who want to use some method, instead of writing their own logic specific method, they will simply use this and call this method. So that's how it starts. Over the time it get very messy. So this is the reason one of the alternative approach is using package by feature. I mean, package by component is also kind of a very in line with this approach. And in addition to these, there are a few other code organization styles like hexagonal or ports and adapter, or some people call onion architecture and clean architecture. So in my view, there are slight differences, but all of them are kind of a very similar. The idea is you have a core domain model, and you need to make it independent of the infrastructure concerns, like that doesn't talk to databases or queues or anything like that. That core domain circle only tackles your business logic. And then you have outer circles that talks about use cases or application services. And then you have other layer, that is the adapters, like you talk to web components or databases, things like that. I have a mixed feeling about these architectural styles. Now, I mean, they are good and created with a good intentions. The whole idea is to be able to test your application without concerning with the external integrations. Fine, but most of the projects that I worked on is heavily depend on the databases, queues, and third-party REST services with a kind of a minimal to decent amount of business logic. So there, my intention is to actually test with all those integrations. That's when I get the confidence. I don't get confidence that my application is working fine by isolating all these important points. They are really important. Like you can say, okay, I'll remove all these integrations like database and all, but database transaction handling is working or not is very crucial for majority of the application. So instead of isolating all those things, I'll try to isolate, but I finally want to test with all those integration components. That's when I get the confidence. Okay, so my personal preference is to go with package by feature, and package by component is kind of a very similar. And if you want to know more on this code structuring, I highly recommend you to watch Simon Brown's this talk. I will share this link in the video description. Modular Monoliths by Simon Brown. Very good talk. You should definitely watch it. So I'm going to do some refactoring to our current code base to make it like a package by feature. So basically, how do I usually organize my application is, so this is basic common thing like whatever the organization name and your project name. After that, I'll try to create a package with a module name. So in our case, we don't have much, but typically it would be something like orders or customers or catalog or something like that. So the module name. Inside that, I'll try to create two packages. One is domain, another one is web. So the idea is this domain model contains the core logic of that particular module. And right now we have only REST API that talks to that domain model and provide the API for it. Maybe in future you might have other consumers also. So for now we have these two components. So within this I put person repository in domain. I put person service also in domain. I'll put models. I'll move these models into domain. I'll move person entity also into domain, and I'll move these web components into this web layer. Now I'm going to delete these three. Fine. Okay, but what got improved? It is kind of almost same, right? So the first change would be I will not make it the repository interface as non-public. It is package scoped. So anybody outside of the people domain should not be able to directly talk to the person repository. They should always come in through person service only. But here we are saying, okay, this is kind of a package protected, but we are exposing it to public. So one approach I usually do is I'll refactor this and I'll extract an interface. So I will leave this rename original class and use interface wherever possible. So my implementation would be called person service IMPL, and I will leave the interface name as person service, and I am going to select all the methods. So what happened? Now there is a person service interface which is public, and we have person service IMPL. I'll remove this public modifier because this is, we don't need to expose these internal implementations outside of the package. If anybody, any other module within our application wants to use, they can inject person service, which is a public one, and Spring is going to take care of providing the implementation component from this service IMPL. Okay, so here we don't need to even make this as a public one, and this is fine. Okay, and models usually you share it with a different layer, so I'll keep them as is. And one important thing is, should we make this as public and share it with other layers? That is an important question. So I would not recommend to share the entities with other layers, but again it depends on the kind of application that you are developing. So usually I would consider this entity as an internal representation of the persistence related component. And nobody who uses person service should not need to know, are you using JPA, are you using Zook, are you using something else? They need not know. For that, you shouldn't expose the person service to the outside world. Instead, maybe you can create another record that represents a person, and you copy all the data into that record and then send it back to the other layers. So that's what I would highly recommend you to do. So instead, right now we are kind of sharing this, exposing this to other layers as well. I guess in some controllers we are using this, but I would recommend, instead of passing it along to the web layers, create a person DTO or something which is a record, and then use that in other layers. So this way your web layer components can only see your person service, and nobody else knows the internal implementations. Only Spring will understand, okay, this is an interface, but this is the actual implementation, and it is already registered as a Spring bin. So this way only you are exposing this interface, and you have the luxury to refactor whatever the way you want to structure your code within this package. Okay, so this is my preference, and I am not doing that actual refactoring here, but this is my recommendation. Like instead of giving a person entity directly back to the web layer, you should create a person DTO or something like that. Whenever you create a person, you go ahead and insert the record, and once you get the record, once you get the entity, copy it back into a record and return that value instead of return the direct entity itself. Okay, so that's my preference. And yeah, I know some of you may be hardcore fans of hexagonal ports and adapters and everything. The point is, there is no silver bullet solution like, okay, follow this code structure for every project, that works fine. That's not the case. You need to weigh in the alternatives, like okay, you want to isolate all the logic, but it comes with a cost. Okay, nothing is coming for free. When you want to isolate the domain without tying up with any of the persistence or queues or web layer, you need to kind of detach them using interfaces and then club them together, right? So that's a cost, and if that cost is acceptable considering the benefits, definitely go for it. Otherwise, don't bother about these complex things. Just go for package by feature, and it also works fine. And I have shared some of my thoughts on this same subject. I have written a while ago. I have written this article called Tomato Architecture. Actually, it is not really an architecture. It's kind of a group of good guidelines. So what to do, how to structure your code, some common good coding practices, not really big architecture or anything like that. But I shared my opinion on this, and again, the name is kind of a funny, like there is nothing specific to tomato or anything like that. It's kind of a satirical way, just like hexagonal architecture. Hexagon has nothing to do with hexagonal architecture. It really doesn't make any sense at all. So as a sarcastic thing, I just named it as tomato architecture. But I would suggest to just take a look at this. I'll share the link to this blog post in the video description. I hope you might like it. So that's all for this video. So we have gone through all of these anti-patterns, and then we have talked about what is the real problem and how to fix those issues. So I hope this video is helpful, and thanks for watching. Bye bye.